Sorry for that. People, can I continue? Okay, I'll start again then. Sorry for that. Good morning, afternoon, or evening to all participants of this MOSTA webinar. Wherever very warm. I'm very honored to be invited. This webinar on 3E industry perspective.
Okay, hi everyone, I'm Mervin. So I'm from SMW Plantations, Research Sdn Berhad. So sorry for IAQUA's technical glitch. So I will move on to our presentations here on 3 MCPDE and GE mitigations in palm oil mill itself. So this is my cover page for my presentations. So I will start with my presentation outlines. So I will start with the company profiles, we as a SMW Plantations, followed by some general information about palm oil milling process and its palm oil qualities. Then I will explain a little bit about the factors and formations of 3-MCPDE and GE, followed by the mitigation strategies and some lastly conclusion. Next. So I will start off with the presentation with these company profiles. We SMW Plantations as a integrated plantations company. So for our company, we have upstreams comprised of the oil palm estates and also millings. And at the downstream, we have the refinery and some food and non-food products and derivatives. So we, myself, is part under support services in R&D, where we aim to assist the mills and the refinery to improve their process efficiencies. Next. So I will start with some general information about palm oil processes and the quality. So this is a general process flow for the palm oil processings. So basically the oil palm fruits from the estate is harvested and then sent to the mill for extractions, and finally we get the edible oils from the refineries once it's processed. So our focus here will be on the milling side. So I will explain a little bit on the milling sites in the subsequent slide. So these are typical palm oil milling process flows. So at the end of these processings, we have two main products, mainly kernel and also the CPO. So for these mitigations, we focus on the CPO that we produce from the palm oil mill. So to illustrate further what is inside the crude palm oil, so you can see that this slide shows that the main compositions of the crude palm oil are triacylglycerols, which is DAGs, with some slight amount of DAG, MAGs, FFA, and some also solid and impurities inside it. So if you see on the left side, there are some antioxidants also present in the oil, which is the tocopherol, tocotrienols, carotenoid, phytosterol, squalene, and also some phospholipid and metal traces, which is the copper and ions. So I show you this crude palm oil composition is because that some of these compounds might affect the formation of 3-MCPDE and GE later. Next. So in terms of crude palm oil quality specifications, everyone knows that we are governed through these program specifications. If you see the first three items, which is free fatty acids, moisture impurities, and also the degree of leachability index. So, however, in light of these three MCPD and GE's issues, new regulations or requirement has been imposed, especially on the chlorine and phosphorus into these requirements. However, these requirements have been temporarily deferred until further notice. Next. So, I would like to, before I start further on 3-MCPD and GEs, I would like to give some background about the 3-MCPD and GEs. So this 3-MCPD and GE is a rising concern in terms of the food safety authorities because it is identified as potential carcinogenic food contaminants. So the EFSA has proposed the tolerable daily intake TDI limit of 0.8 microgram per body kg weight of 3-MCPDE. And the joint FAO and WHO also proposed tolerable daily intakes of 4 microgram of 3-MCPD and GE combinations for the body intake as well. So we further investigate on research has also been investigated on the 3-MCPD informations in the vegetable oils, and we found that the crude palm oil, the refined palm oil, contain the highest amount of 3-MCPD and GE. So from the EFSA has proposed that we from year 2021 onwards, we need to limit the food contaminant of edible oils, especially the palm oil, with 3-MCPD E at 2.5 ppm and below, and the GE below 1 ppm. Next. So the question here is, how can we mitigate these process contaminant issues in palm oil milling itself? So to understand that how we can do the mitigations, we need to first understand how these process contaminants is formed. So in this part, I will explain to you in a macroscopic perspective view in terms of the formations and the factors. I believe later I asked Shams for his another presentations. He will also explain a little bit in terms of the microscopic perspective, where he will show the possible pathway of the formations. Next. So in general, these are the things that we need to know in terms of formations of the 3-MCPD and GEs. So first thing first, 3-MCPD and GE is not present in the CPO. This 3-MCPD and GE actually form in the refined oil during desalinizations at high temperature. So it was suggest that 3-MCPD E and GE formations are produced through DAG or MAG, while acyl oxyanium ions as intermediate in the presence of heat. Also, 3-MCPD's formations involve chlorinated compound. However, the GE does not involve chlorinated compounds. So some of those people was asking about how about the virgin oil, for example, virgin olive, is it present? Is this 3-MCPD and GE present inside? The answer is no. However, if you buy this 3-MC virgin oil, then you detected these 3-MCPD and GEs, it indicate that your oil is not purely virgin oil. Next. So move on to the factors of 3-MCPD and GEs. So for 3-MCPDEs, it was clearly known that the precursors for 3-MCPDE is chlorine, or we call it chlorinated compound, and also acyl glycerols. So we have DAG and MAGs, as I mentioned earlier in the crude palm oil compositions, which also is the precursor for the 3-MCPDE. However, in terms of DAG, and MAGs, the reactivity of DAG is the highest among these three acyl glycerols. The others two is, other than that, is the temperatures also affect the 3-MCPDE. Heating times, durations also affect the 3-MCPDEs. And I also include one things which is FFA. So there's a lot of argument whether is it FFA affect the 3-MCPDE and formation? Yes. Some will say yes, some say no. So what we can understand here is this FFA actually indirectly affect the formation of 3-MCPDE, because when the high FFA is high in the CPO, it actually increase the acidity of the oils, which eventually increase the rate of reactions for 3-MCPDE. So next, we go to the GEs. So as we know, the precursor here is the DAG and MAGs. So as I mentioned earlier, no involvement of the chloride ions. So another factors here will be also temperature and heating, same as 3-MCPDE. Next. So to further investigate the precursors effect on the 3-MCPDE formations, my colleague here, Dr. Tiang, has presented these correlations of 3-MCPDE and chloride contents with the R square of 0.73, and this correlation result has been published in one of the ACS papers, showing that this chlorine is highly correlated to 3-MCPDE. Next. So as we know now that chlorine is the precursor for the 3-MCPDEs, so we need to identify what is the source of the chlorines. So I break this part to 3 parts, which is now the first is the palm oil fruits. So the possible contact of this chlorine source in the palm oil fruits, possibly due to the soil irrigation or even pest controls chemical use. Secondly, trash or fibrous materials that we collected during the harvesting and sent to the mills along with the FFB also might contaminate with chlorine sources. These have to do with the harvesting technique, handling, and transport. And lastly, the water source that we use for our water processings. So these are the 3 items that potentials as the chlorine source for the 3-MCPDE formations. So one of my colleagues done some study on the sphingolipid organochlorine content in the palm oils. So we did some mapping on these organochlorine contents, and you can see that in the salicylic condensate and EFV bunch liquor contain the highest sphingolipids organochlorine contents, and it was low for others processes. However, I would like to take note that sphingolipids organochlorine contents is one of the most abundant organochlorine species in the palm oils. So in general, we have like more than 200 types of organochlorine contents, but this sphingolipid is among the highest one. Next. So based on the earliest findings, we further investigate on the total chlorine contents and 3-MCPD in the palm oil millings, especially in the dilution factors. So if you can see the oil without any dilutions, before the clarifications, the original's chloride content is high. But after the dilutions with the water, we can see there's almost 50% reductions of the chloride contents, which also eventually translates to lower 3-MCPDE. However, we tested on different sources of dilution water, which is salicylic condensate and also salicylic condensate with EFB liquors. We found that there's an increase of the chloride contents as well as the 3-MCPDE after the dilutions. That's why we need to be careful when we select type of water we use for the dilutions. Next. Next, I move on to the GE formation factors. As I mentioned earlier, GE formations are predominantly because precursors are predominantly DAG and potentially also MAGs. So in these slides, I show you the hydrolysis reactions of normal typical vegetable oils, including the palm oil. So if you can see that TAGs react with waters under certain conditions, it produces fatty acid and DAGs. And there's also potential that some of the DAGs further degrade down to MAGs under the same hydrolysis process. Thanks. So I believe most of the miller understand these slides and aware on these two typical hydrolysis reactions in the millings. So just to sum up, enzymatic hydrolysis occurs before the sterilization process, and autocatalytic hydrolysis occur before and after the sterilizations. Because these hydrolysis eventually also increase the FFA. That's why the millers need to control the FFA. However, we also note that if you can control your FFA, you also can control your DAG level, which I will explain later in detail on this. So after I explain through what is the factors and the formations of the 3-MCPDE and GEs, so now we move on to some potential mitigation strategies. One is how we can reduce the precursor of 3-MCPDE, and second, I put it more general terms, improvement of the oil quality to mitigate these issues. I will explain this one also in the later slides. So to understand the mitigation strategy, first we need to understand what is the root cause. So as we know that the precursors are the root cause for the process contaminants, which is the chlorinated compounds, acyl glycerols, and potentially also maybe FFA. So from this way, we can zoom in and target what we need to do as a solutions. So in terms of 3-MCPDE mitigations, we first need to address the chlorine mitigations. So for this part, I actually divide to two parts, where one is we directly reduce the chlorine source. Another one is we reduce the chlorine source from the CPO itself. So in terms of reducing the chlorine source, there are two methods that we try out. One is we do some cleaning on the palm fruits, and another one is segregations of the poor quality oil. In terms of CPO, chlorine reduction in CPO, we also tested two methods. One is the CPO washings, which is very commonly known, and also CPO dechlorinations. I will describe in details for these four methods later. So if you can see, for the palm fruit cleanings, we introduce dry and wet cleanings to remove the precursor of 3-MCPDEs, which is the chlorinated compounds. So with this method, we actually able to remove a high amount of traces and able to reduce up to 30% of this total chloride content. However, the cons for these methods is it involves high capex and high maintenance because we are dealing with solid materials. Secondly, is on secondary oil segregations. So with this method, we actually screen out those secondary oils such as condensate oil or even the EF bilicals. So with these segregations, we have a cleaner CPOs, and the secondary oils we term it as technical grade oils. The good part for this method is we also able to reduce up to 30% of the chlorine contents, and we found that the segregation of this oil we will produce a better quality oil. However, if this secondary oil is not properly recovered, you will induce high losses in the waste stream. The third method, I think this is a most common method used, be it in miller or refineries, is these CPO washings, where we wash the water, we inject the water in, mix, and then separate out to reduce the total chlorine. And these methods are efficient, can reduce up to 80% of this chlorine compound in these CPOs. However, this method increase the amount of wastewater use, and also is costly. The last method here is the applications of SMBS. So in this method, we actually mix this SMBS in the CPO, mix it, stir, and then we filter it out. And we found that this result in TC to below 2 ppm. However, the downside of this method is the SMBS cost is very high, and also high losses in the spent SMBS. Next. So as I mentioned earlier, improving oil quality is one of the mitigations methods. So the question here is, how does this improving oil quality help to mitigate the 3 MCPD and GEs? So what I'm saying here is, by improving the quality, especially the FFA, first thing first, if you can reduce the FFA of the CPO, actually you're able to reduce the DAG formations, and which is the precursor for 3M GE. And at the same time, you're actually able to reduce the acidity of your oil. By reducing it, you're actually able to reduce the rate of reaction for 3-MCPDE formations. So how can we do this? I will show you this in the next presentation. So what we need here is to minimize the hydrolysis formations. So as I mentioned earlier, we have two types of hydrolysis. One is enzymatic and one is autocatalytics. So to address the enzymatics, which is also the main formations of FFA, we need to tackle through the fruit qualities assessment. So how we can improve the fruit quality? First, we need to have a proper fruit handling, improvement of the harvesting intervals, and also the fruit freshness. If on the other hand, the autocatalytic process, we need to improve through our milling process conditions, which is the processing time, the oil segregations, and also the amount of moisture content in your oil. Next. So as the result of these implementations, our SMW plantation, actually we have different grade of CPOs, which with the implementation of above, we have this oil so-called superior CPOs and also premium oil CPOs. If you can see that the difference here between the normal standard CPO, first is the FFA contents. One is standard per specs below 5%. The other two is below 1.2 and 1.5, 1.5 and 1.2% respectively. So, and if we go through, we see that with these implementations of proper fruit qualities and also the process conditions, we're actually able to reduce the TC and also result in a lower 3-MCPDE and GE formations. So these are some results that we shown here is the result based on a commercial trial through physical refining roads. We also noticed that if this oil undergone chemical refinings, the result is even much better. Next. So to sum up the whole improvement of these oil qualities, it must be throughout the whole supply chain, which is starting from the plantations, where we need to optimize the harvesting intervals, reduce the handling methods, and also minimize the trash contents. And lastly is the evacuations. In terms of palm oil mills, what we need to do here is no recovery of secondary oil, immediate processings, and also minimize the CPO storage in your storage tanks, meaning to say you need to dispatch your oil as fast as possible to the refinery. In terms of the refinery, I will leave it to IR Shams for his presentation later. So I will sum up my presentations for the conclusion part. So there are 4 points that I would like you all to take home as a message. First, 3 MCPDE and GE is only formed in refinery and is not present in the CPO. Secondly, the precursor of 3 MCPDE are chlorine content, while GE is DAG. Third, mitigations is proposed to start at estate level, followed by mill, and then lastly, refining process improvement. Lastly, we need a collective efforts from planters, millers, and refiner to mitigate this process contaminant issues, because what we have in SAMW as an upper hand, because we are integrated plantation companies, and we're able to solve this together between the planters, miller, and refineries within the companies. So with this, I would like to this is some reference that for you guys for these my presentations. So I would like to say thank yous for your attentions, and I'd like to acknowledge these are the members that helped me in these presentations. Thank you.
Yeah, thank you very much, Engineer Mervyn Chu. I'm very sorry I couldn't introduce you.
Yeah,
but
it's
you
okay.
certainly have lived to your CV then. So I'm told that I have to make up for good time. That was a very good presentation. Thank you very much. I'm told now that I need to introduce you now properly. So guys,
Okay.
very sorry for that interruption. It was, I think, bad connection on my part. So Engineer Chen Lai is a chartered engineer in chemical, as well as a professional engineer in mechanical. So he's really got the best of both worlds. And he's been working with SAMW Plantation since 2011. And he holds a double degree, I would say from Germany, since I can't pronounce the name, as well as UKM. And
Okay.
the work that he's been doing, and you can see from the presentation, is focusing on the all mill process improvements and also on quality enhancement and efficiency optimization. And he supports the palm oil mills on technology evaluation and a lot of other things, including troubleshooting works. And he is also experienced conducting researches and transforming laboratory tests into pilot plant and commercial scales. Now, it's not surprising that he's contributed 5 patents and 10 publications on mill process improvement related area, because I know that he's still continuing his further studies, and that's why he's so eloquent in this then. By the way, I'd just like to mention that in, I think it's 2018 then, Mervyn also won the iChemie Young Industrialist Award, yeah, which I think is fantastic. So Mervyn, thank you very much for that presentation. And just before I go on to the next presenter, I know that all of you would have had a lot of questions you want to ask. And so what I'd just like to ask you is that when you ask the questions on the chat, I think it's on the chat, you can do that. Please also at the same time state your name and the organization you come from. I think that will help the speakers to better answer your questions. And at the same time, if you want to make reference to any slide number, please do so that I think the rest of the participants can also follow the questions that you're asking. So I think we should now go on to our next presenter, as Engineer Mervyn Chu alluded to, which is in the refinery. So I'd like to introduce Engineer Sham Lakshmanan. Yeah, so Engineer Sham Lakshmanan is also a chartered chemical engineer, and he's also a first grade steam engineer. So he has worked initially as a process engineer in the edible oil industry, and then he moved on to the chemical industry. And he has worked overseas, and his international experience includes mineral processing plants in China and Indonesia, as well as in Western Australia. He's also a certified energy manager, where he leads the energy and resources saving projects, and he's really passionate about environment conservation. He's also a chartered scientist, so he has got the initials, the what you call it, suffix after his name, CSI, and he has authored a number of journals on pollution prevention in the chemical industry. and he currently guides the research and development at IOI Sandakan's refinery to reduce 3 MCPD and GE in oil palm products. So with that, I'd like to ask Engineer Syam Laksamanan to give his presentation from the refinery side. Over to you then, Engineer Syam.
Hi, good morning, good afternoon, good evening to everyone, and thank you, IIR Kwa, for the flattering introduction. For everybody's information, Engineer Kwa is actually my mentor, and he contacted me some time ago, baiting me about 3MCPD and GE, and he got me really hyperventilating about the topic. So he said, hey, why don't you present a topic on this? I didn't realize he was actually baiting me to present. So as my mentor, I couldn't really turn him down. So I actually signed on for this unknowingly. It was a very good trap by Kwa. Thanks, Engineer Kwa. Okay, allow me to first introduce my company. If you can move to the next slide. Okay, IOI is palm oil refining complex based in Sandakan, Sabah. It is quite an integrated complex that is built over 60 acres. You will see it is in the midst of lush greenery. I showed you those two pictures there. We have our own water treatment plant. You can see the catchment ponds at the back. We have our own biomass boiler, which takes EFB from the nearby mills to produce both steam and electricity, which it supplies to the adjacent facility. And we have got 3 refineries in that complex, 4 dry fractionation plants. We have 3 kernel crushing plants. We have 2 palm kernel dry fractionation plants as well. Also with an integrated effluent treatment plant, and we recycle close to 85% of the treated water within the complex. We have got tank farm with a capacity of about 200,000 tons, and we are also connected to our own jetty through which all our liquid products are exported. You can see in the background the waterway, that's where the ships come in. The jetty is not captured in these 2 pictures. If you have any questions, please refer to the slide numbers shown here, because there's a slight difference between the slides that were sent out earlier and the one that I'm presenting now. Do not use the earlier slide numbers. For those who have already asked questions before, we have already taken account of those slide numbers, and we will answer those questions, if not in this presentation, at the end of the presentation. Okay, we set up an R&D department mainly because of the 3MCPD and GE issues. Of course, now we do other things as well. We have a very young team here in Sandakan who have put their energies and ideas to work on tackling the 3MCPD and GE issue. Because 3MCPD is quite a mouthful, we do often call it 3M, and I may occasionally use the term 3M here too. So when I say 3M, I'm actually referring to 3MCPDE. MPOB gave us a grant for the CPO washing project in our Sandakan plant. Thanks to MPOB. We also want to thank our MD, Dato' Liao Cho, for his strong support and vision and his openness to share our findings with industry. Now, one really good thing that has happened as a result of 3MCPD and the GE issue is that many of us who have started to take palm oil for granted had to relearn about palm oil and its triglycerides. 40 years ago, when I started working, triglycerides was a mouthful. Today it's called TAG. And then we have the DAGs and MAGs, epoxide rings, acyloxoniums, and many, many more fancy names like phospholipids, glycosphingolipids, which are all Greek to me. Yes, there is some chemistry involved today, so do bear with me. This will be exciting for those who appreciate the chemistry, but for the others who are a bit faint-hearted when it comes to chemistry like me, don't worry, you will still be able to follow this too. It's not only for scientists. Okay, a disclaimer, we do not claim to be experts. We are here to share our experience on what we have learned along the way. If you do find errors in our findings and can guide us or can contribute to our thoughts, we would be most grateful. The contents and arrangement of the presenter are shown here. We will look at the targets. Then we will look at how the several pathways of 3-MCPD formation. Of course, Engineer Mervyn did a very good presentation earlier, so I will not have to go through this in detail. We will look at some of the mitigation in lab scale trials, and then it will be followed by some of the results obtained in our plant. That ends the 3-MCPD portion of the presentation. Then we continue with the GE formation pathway. This is followed by something that we mentioned, which is a correlationship between 3-MCPD and GE. Co-relationship. I'm not saying correlation. We will explain it in the presentation. Then we will look at the GE mitigation that was conducted in lab scale trials, and it will be followed by results obtained in the plant, and then a summary of sorts. Okay, next, please. Okay, this is the limits that have been set by, I'll say MPOB for 3-MCPDE. For palm oil, it is 2.5 ppm by January 2023, and for GE, it's 1 ppm by January 2023. Whereas for the soft oils, including palm kernel oil, the limit is 1.25 ppm for 3-MCPDE and 1 ppm for GE. But as it is, there's already inquiries from buyers for lower levels than this, generally for the soft oil, for PK or palm kernel oil. Next, please. The pathways. Okay, what we're trying to show here is sort of like a treasure map, you can say. This is not created by us, but it is research from literature that shows the various routes through which 3-MCPD may be formed in the process. And you'll see here you've got various arrows pointing at various directions, and since it's difficult for me to actually use a cursor here, probably I will explain it in the next slide. Next slide, please. Okay. What you see here is TAG, triglycerides, that lose a fatty acid due to high temperature and presence of moisture, and forms DAG. And that DAG, with the presence of chlorides in that high temperature environment, can then become 3-MCPDE. The picture on the right-hand side is no particular deodorizer. Okay, it's a deodorizing column. Now, this is where you have all the required ingredients to form 3-MCPDE, which is the high temperature conditions, which in palm oil refineries, it's close to 260 degrees, or if not higher. And you also have got steam being injected into the deodorizer for sparging, for removal or stripping of the impurities. But it also presents the opportunity for moisture to form, which is also another ingredient required for TAG to become DAG. Next, please. The next slide here, if you look at the right-hand side, the pictures, the top picture shows you what is actually happening in the deodorizer. You have got a column of oil sitting on the trays, and you have steam lift pumps. You have steam being injected at the bottom, and the steam bubbles, as they enter the deodorizer, they actually encounter very strong vacuum. So the bubbles rapidly expand and push out the palm oil through the top displacement covers and deflection covers. And in the second picture, the picture below it, you can actually see the oil splashing out at the top of the deodorizer. Now, what this does in effect is it creates a circulation within the tray to allow large surface area contact and proper stripping of the impurities in the oil. The lowest picture shows the steam lift pump, or sometimes also called the mammoth pump, and how it works. You have got oil being drawn in because of the steam upward movement. Now, on the left-hand side, the formula shows, again, you have DAG, diacylglycerol, that can, diacylglyceride becomes straight away by the loss of fatty acid and substitution with chloride, becomes a 3-MCPD monoester. And like Engineer Mervyn mentioned just now, you have got FFA in the deodorizer as well. That FFA can combine with this monoester to become your 3-MCPD diester, both of which are actually 3-MCPD esters, and which are both harmful. Next slide, please. This is another pathway that is shown on that treasure map that I showed you earlier. Again, you'll see DAG can become an acyl oxonium, and then again with chloride coming in, it can become a 3-MCPDE. If you look at all these, I refer to pathway 1, pathway 3, pathway 6, right? They are all referred to the particular pathways in that map shown in the preceding slide. Next slide, please. This is a summary of all the pathways. Now, what you can see is from that map as well as the subsequent slides, you have triglycerides and monoacid glycerides that can become diglycerides, and then with the presence of chlorides, they become 3-MCPDE. You have DAGs and MAGs, again with reaction with chlorides, can become 3-MCPDE. And TAGs and DAGs can become acetoxonium, with chloride reaction become 3-MCPDE, and the DAG can become epoxide to become 3-MCPDE. That last one will be referred to again later, but the rest of it shows how we can actually form 3-MCPDE. Now, the TAG, DAG, MAGs are all present in oil. It's not something that we can eliminate in oil, or even the DAGs may be formed during the refining process. Like when you have a triglyceride and you have FFA is forming, the FFA forms because a triglyceride is split to the free fatty acid and it leaves behind a diglyceride. So this is unavoidable. So the only foreign material here that we can say is that chloride. And since it is a requirement for chloride to be present to form 3-MCPDE, the route taken by most researchers is to remove the chloride from the equation. So if you were to remove or minimize the presence of chloride, then the chance of or the amount of 3-MCPDE that forms can be reduced significantly. If you remember your chemistry, look, basically a chemical reaction is the successful collision of reacting particles. So by reducing the concentration of the chloride in the palm oil in the deodorizer, we are reducing the probability of that reaction occurring and therefore reducing the formation of 3-MCPDE. In terms of scale, the chloride content is in ppm, whereas the DAG is in percent. So the DAG is already way in excess in terms of being able to combine with the chloride to form 3-MCPDE. So the challenge is actually to try and reduce the chloride as much as possible. Now, another approach, another thinking that has come about is in the palm oil, there is a lot of inorganic chlorides. And what we have done is we've looked at how we can remove that inorganic chloride because they form a substantial portion of the chloride presence in oil. And one of the good things about inorganic chlorides is, if you remember your chemistry again, most of the chlorides are highly soluble in water. So just using water would be a very good way of just removing the chlorides, which is again an approach taken by most of the refiners. We're going to go back to a bit of chemistry now. And can I go to the next slide? Okay, if you look at the bottom left-hand corner, you will see the glycerol molecule, right? The glycerol molecule reacts with fatty acids. You'll see two fatty acid molecules with R1 and R2, which then forms a diacylglycerol. Of course, if there were three fatty acids combined with glycerol, it becomes a triglyceride. The triglyceride is captured on the top right-hand corner. Okay, now these are present in the oil, and there's no way we can do without it. If you talk about only one fatty acid reacting with the glycerol, it will form a monoacylglycerol, MAG. Next slide, please. Okay, I'm going to come to the experiments that we did in the lab. We did, in the left-hand side, we did batch washing, which is, these are all done in duplicates and in multiple repeats. We did a 50-50% mixture of oil and water. We heated up and stirred it, and then we decanted and removed the oil and did further tests, whether it's bleaching and followed by deodorizing and quality tests and all that. And the right-hand side shows column studies that we did. We did a measuring cylinder, and we actually injected water into the bottom of the column so that the water actually drips or drops. Oil droplets migrate to the top due to the difference in the density between the water and the oil. And once we collect, there's a stirrer running as well, so you can see the swirl in the second picture there. Then after it's settled, we pipetted out the oil and then put it into a second column and again repeated it. And then we checked the quality that we got and did further experiments with that to see how easy it is to remove the chlorides. Next slide, please. Basically, this summarizes what is actually being done by what we call washing. You have chlorides present in the mixture, and by introducing some water into the system, they're trying to move that chloride into the water phase, so that there is less chloride left to react with the DAGs or the other precursors to form 3-MCPDE. And basically, if you look at it, remember we mentioned that most of there's a substantial portion of inorganic chlorides in the CPO. Now, that inorganic chloride mainly resides in the moisture content in the CPO. Let's say your moisture content of CPO is 0.1%. That chloride is in that moisture content within the CPO. Now, let's say in CPO washing, we add 5% water. Typically, that's the figure that's been touted. That's about 5%. What is basically happening is the chloride content in the moisture is actually being diluted. If you talk about a figure of 5% and 0.1%, the dilution is 50 times. So the chloride level in the CPO drops 50 times. This is basically what's happening. Although we call it CPO washing, it's basically a dilution that's taking place. Next slide, please. We tested various CPOs coming to our refinery, and you'll see that we tested inorganic chloride, organic chloride, and total chloride. These are done from time to time, and it basically gives us an idea of what is the quality of the incoming CPO and what we're going to get once we refine the oil. You'll see there's a wide range in the organic chloride content in the oil. Now, we've highlighted some of them. If you look at number 9 and compare it with 17, you will see that the total chloride is 11.7 for 9, whereas for 17 is 11.6. If we were to wash it and refine it, we would probably expect to get similar 3-MCPD levels. But if you look at the organic chloride column, you will see that for column 9, for row 9, it is 2.1 organic chloride, whereas for row 17 is 3.8. Washing removes mainly the inorganic chloride. So the organic chlorides do not reduce much. And as what Engineer Mervyn had presented just now, those chlorides, whether they are the presence of sphingorganochlorines in the CPO, these do contribute to the formation of 3-MCPD in the deodorizer. If you look at the row 5 and 13 again, you will see the ones highlighted in yellow. You will see that the total chloride is 4.8 versus 4.6 in row 13. And if you were to wash it, you would expect maybe the 4.6 to get a lower 3-MCPD. But in actual fact, because the organic chloride content is higher in row 13, it results in higher 3-MCPD levels compared to the one in row 5. Next, please. Now, the organochlorides, as mentioned by Engineer Mervyn, there are many possibilities of organochlorides existing in the CPO. Here we've shown you the presence of some, where you have, in the first case, wax ester with a chloride already in the molecule. Same with the fatty acid in the next row. Diacyl glycerol organochloride, the third one, again with a chloride already in it. And the last one, if you want to see what a sphingolipid organochloride molecule looks like, these are materials that are produced in the mesocarp of the oil. So you'll find that the presence are greater in the CPO rather than in CPKO. And washing will not really remove them. So this becomes a challenge for refinery unless we can actually tackle it through the whole supply chain. I like what Engineer Mervyn Chu said just now. This has to be a joint effort along the whole supply chain, from planters to millers to refiners, in order to be able to bring the levels down. Next, please. Okay, we did some washing of the CPO. On the left-hand side graph, you will see comparison of 3 sets, which is with good CPO, regular CPO, and mill CPO. Again, these tests were done in duplicate and repeated several times as well, with different quality of CPO. And basically, the trend you can see is just washing the CPO results in lower 3-MCPD levels. And you can see with good CPO, You can even get good quality with just unwashed CPO, right? And another interesting thing is the best results are obtained from fresh production from the mills. Whether washed or unwashed, the best results are obtained if you were to be able to process it as freshly as possible. Now the graph on the right hand side is looking at what happened to MCPDE, and or to identify where is the best place to position the washing stage. When we say pre-wash, we're saying washing being done before bleaching, a pre-bleaching washing. Post-wash means post-bleaching washing stage. And the final one is we did both pre and post-washing. Now, if you look at the good oil, with good oil, in all cases, it kept reducing. So without washing, it was already good MCPDE levels. If we did a pre-wash, pre-bleaching wash, we got lower. If we did a post-wash, separately, without doing pre-wash, we actually got lower as well. And if we did a pre and post-wash, it was even lower still. But when we actually process with regular oil, the quality, regular oil is all shown at the bottom of the quality that when we talk about the good oil, regular oil, and fresh oil. It's all shown at the bottom of the slide. When we tried with regular oil, we got varying results. And this was repeated again when we did it again. So it actually depends on what is coming in with the CPO. So if the CPO probably has more DAG in it, we may have a tendency to form more of these unwanted byproducts. Next, please. Now, when we watched the CPO, we actually found that the appearance was actually strikingly different. If you look at the picture in the middle, that shows you what a picture of the unwashed CPO. The IOI label is stuck in it so that you can see it's actually quite opaque. You can't see through and read the IOI label. Whereas when you wash the CPO, you can actually see through and you can clearly read the IOI label. The reason is because the pictures don't actually capture and tell the complete picture. You've got to actually visually see it to appreciate that there is a difference, a significant difference in the quality of the CPO when it is washed. And we analyze that further to see what other substances are being removed. If you look at the table at the bottom, you'll see we analyze chloride, phosphorus, magnesium, calcium, iron, zinc, tin as well, right? And you'll see that all of them actually reduce. Now, all of this actually impart greater oil quality as well as greater stability of the oil. There are also research papers that have identified that substances like iron, zinc, and stannum do catalyze the formation of MCPDE. So its removal is actually encouraged. And removal of calcium magnesium is also good because calcium magnesium also interferes with the degumming of the oil. They also consume some of the phosphoric acid that is used in the degumming process in the refinery. So yes, there is a lot of improvement in the oil just by washing it. Next slide, please. Okay, these are some of the results we got with 3-MCPDE when we ran our centrifuge. We have a centrifuge here. Like I mentioned, we got the grant from MPOB. And you'll see when we didn't wash, we were getting 3-MCPDE levels of between 4 and 5. But for the months that we ran the centrifuge, you can see that we basically met that new level that is specified by MPOB. All the levels were slightly above 1, the average figures. There were occasions when the maximums were at 2.5. But overall, it met the new limits being specified by MPOB just by washing the CPO. Next, please. There's another slide again showing what was our 3-MCPDE levels before we did washing and what we achieved after washing. And what is shown at the top there are some of the additional equipment. You have a degumming vessel as well as a vacuum drying vessel as well for the process. It's not just the washing. There's quite a lot of equipment that comes together with it. Next slide, please. We tried to develop correlation between 3-MCPDE and the chloride level in the RBD palm oil. And from here, you can see that we got quite a good correlation. And it shows that if you have chloride of 1 ppm, you would have about 0.9 3-MCPDE. That means almost all of that chloride in the RBDPO exists as 3-MCPDE. Now we took this further on the next slide, please, to try and see if we could predict what it would be. This is the wash CPO that is going to the deodorizer, the quality of the wash CPO. And again, we got a correlation of between 60 and 70%. So if you have chloride of about 2, you're looking at something like 1.4 ppm 3-MCPD in the final oil. Why did we do this? This is a question that's been asked by some attendees. It's mainly to help us predict what's going to happen, because using the equipment that we have here, the GCMS, it takes quite a bit of time to get the results, and we can't afford to wait more than 24 hours to know whether we are actually achieving quality or not, being an ongoing refinery operation. So we've been actually trying to develop quick methods of identifying what would be the expected 3-MCPD levels in the refined oil. Now, I do need to caution that this may apply for my plant, but each plant may have to develop its own correlation depending on your operating parameters and your chemicals, your bleaching use and all that. Huh? So, but basically, a correlation can be generated from it. Next, please. Now, this is to stress further that the organic chlorides do play a part. If you remove the inorganic chlorides, it is not the end of the problem. Okay, if you look at the first table on the right-hand side, top right-hand side, you will see that is the quality of CPO, the total chloride, inorganic chloride, and the organic chloride content. The next table is the quality after we wash the CPO. It shows the inorganic chloride has dropped significantly. From 5.81, it has dropped to 0.12. And from the last one, row 5, from 4.85, it's dropped to 0.1. You'll see the organic chloride has dropped a little bit, right? Now, when we refine that quality of oil, you'll see the 3-MCPD levels. The 3-MCPD levels are ranging from 0.78 to 2.46. Again, it cannot have come from the inorganic chloride. It has to have come from the organic chloride. That's what we're trying to show in this slide. So it is important that we do also address the organic chloride in the incoming CPO. Next slide, please. Okay, just to summarize the advantage and disadvantage of CPO washing. One of the advantages that we've noticed is there's reduced bleaching agent needed, and as a result of which you will have lower oil loss. It removes most of the water-soluble chlorides. It also helps to reduce the phosphorus content. Not all, but there's some reduction in phosphorus. It reduces the trace metals and it reduces the impurities. The disadvantages are there is a higher water consumption, and as a result of which there is more water to be handled, which goes to the effluent treatment plant. And depending on how you configure your plant, you may need to heat up this water because there is certain optimum temperatures at which this washing or dilution should be done. And there is also some oil loss in that water. I put a star there because it is explained in the next slide. Can I go to the next slide? Now, this is a picture of, the top picture is a picture of the CPO. The picture with, first picture with 4 bottles in it. First is the CPO, then after that is the washed CPO. The next bottle is the vacuum dried CPO in the plant, and the final is the washed water appearance. The 2 pictures on the top are the water leaving the centrifuge and the quality of the water leaving the settling tank. This was the original settling tank that we had. So we found that the settling tank was not doing a very good job. We did replace the settling tank with a new settling tank that is shown here. And you'll see that the bottom picture shows you the quality of the water coming out from that settling tank. And the graph on the left-hand side shows you a significant reduction in the oil content in the water leaving that settling tank compared to what we used to get earlier. We have managed to reduce the oil content so that the burden on the effluent plant is not that significant. It is there is additional load going to effluent treatment plant, but it was not as bad as what it was previously. Next slide, please. Okay, that concludes my session on the 3-MCPDE. Now I go to the formation of GE. GE, again, you need the main precursor is DAG, and the pathway shown here, and you could have various fatty acids from palm oil that could contribute to forming the glycidyl ester. My figures here vary a bit from what Engineer Mervin has shown. We show DAG typical values ranging from 6 to 7. I think he said 3 to 7, I think, right? Okay, so next slide, please. Now, remember I mentioned about the correlationship between 3-MCPD and GE. Now, these two slides will actually explain what we mean. If you look at this reaction, the GE in the center, GE is actually quite an unstable molecule. The epoxide is quite an unstable molecule, and the presence of many substances could actually break that epoxide ring. And one of those that could break it is chloride. And if you have chloride reacting with the epoxide, you will see it's an equilibrium reaction that can either form 3-MCPD on the left-hand side or 2-MCPD on the right-hand side. But if you look at those equilibrium reactions, right, if you look at the length of those arrows, it'll show that there's a greater predisposition to form 3-MCPD and 2-MCPD rather than to reverse back to GE, which means that GEs can easily be converted to 3-MCPD or 2-MCPD with the presence of substances such as chlorides. So there is some formation taking place, and the reverse is less likely to happen. Let me explain why we say this in my next slide. Now, if you look at this, this is a graph showing our own plant record of 3-MCPD and GE while it is being processed in the plant, right? Now, if you look at the trends in this, right, you will see that it's almost a mirror image. Again, unfortunately, because I can't use a pointer, I can't actually show you that. If you look at it on the left-hand side, extreme left-hand side, if you look at the graph, when the 3-MCPD starts to drop, you will see the GE rising. The 3-MCPD is dropping, very likely indicating that there isn't much more chloride left in the oil to form 3-MCPD. So the DAG actually forms GE instead. And that is why you have them going in opposite directions. And if you look at the second green ring, you'll see again where they actually go in opposite directions again. When the GE comes down, the 3-MCPD rises, and again they go in opposite directions. And you can see this throughout. Where I've circled it, you'll actually see, you can almost put a mirror in between and you'll actually see a mirror image. In the last two graphs, they even cross each other. The GE drops below the 3M and the 3M shoots up, right? So to say that there is no relationship, most research says there is no relationship between the two, but this, in our plant at least, it seems to indicate that there is something going on and it is worth further study. Okay, next please. Now, interestingly, when we did washing of the CPO and we monitored the GE, again, the GE did drop, and this was again duplicate, and we've actually repeated over time with different oils. And although the reduction is not as large as you would see with 3-MCPD, there is some reduction in the GE as well. So there are some other impurities in the oil that could be contributing to catalyze the formation of GE. So with good CPO, you'll see that when we washed it, we actually got lower GE levels. Regular CPO and mill CPO. Again, we got best results with fresh CPO from the mills. I think it is to be expected. The graph on the right is again the same as what we did with the 3-MCPD, which is to determine where is the best place to position the washing stage. And again, it indicates, I think if we compare for both GE and 3-MCPD, probably the best position will still be to install the washing stage just before the bleaching stage. Next, please. Okay, can I go back to the previous slide? Okay, if you look at all these graphs, you will notice that we did not achieve the 1 ppm. We'll have to admit we have not been able to bring it below 1 ppm, except for if you look at the last one where the mill CPO, where the washed mill CPO was just marginally below 1 ppm. But in all cases, in all other cases, we have not been able to do this in the plant. And then we started to study, see what is the primary cause for this higher GE level. So next slide, please. So temperature. Temperature seems to be a major contributor to the formation of GE. And if you look at the rightmost graph where we did lab scale refining at 280 degrees, we got beautiful color, 2.1. Drop it to 260, still good color, 2.3. Drop it to 250, we got 2.7. But at the same time, the GE is dropping. In order to achieve GE below 1, just marginally below 1, we needed to go to as low as 230 degrees. And that resulted in RBD PO color of 3.5, which would not be acceptable currently. Even at 240 degrees, we only managed 3 red, which again would be not acceptable. So this is an area that probably needs further work and also post-treatment. Next, please. Now, we did try some post-treatment. You see, from our deodorizer, we had GE level of about 4. And then we tried adsorbents, and we were able to bring it down, but again, just marginally above 1 ppm. But it shows that there are possibilities of reducing the GE post-deo. Next, please. Okay, this one we did in the plant. We had a GE of about 4 ppm. The next bar is after we bleach the oil. You'll see that there's a significant drop in the GE levels just by using bleaching earth. And then when we send it back through the deodorizer, it bounced back up again. This is from one plant going to a second plant's deodorizer. And when we repeated that without any bleaching, we had again about 4 ppm GE. Without the bleaching agent use, it jumped up by about 1 ppm. So we haven't been able to achieve it. But there's one problem, the deodorizer, I think the problem is with the design of the deodorizer. It's because it's not optimum for stripping the GE, but the concept seems to be doable because we tried it in the lab, and with thin film, we are able to get removal of the GE, more successful removal of the GE. Next, please. Okay, we tried to do correlation between the olein and palm oil, because in most cases we sell olein, and whereas we refine palm oil in the refinery. So I wanted to see how much of the MCPDE migrates to the olein. So on the left-hand side, we tried to do a correlation chart, and you can see that it's about most of it. I mean, a substantial portion goes into the olein. And if you were to do it for your own plants, you may get your own correlation. In our case, we got something in excess of 10% going to the olein. So it's higher in the olein compared to palm oil, and it's lower in the stearin. And we also tried to do a correlation between GE and olein and palm oil. Again, we will also be able to get quite a good correlation. And again, it applies to our plant. Of course, the levels are too high to be acceptable. It's starting from 3, so it's nowhere near the region that we want to be. So we'll have to actually develop it further when we come down to lower GE levels. But again, the GE concentrates in the olein. Now, the reason we've done these studies is to see what we need to achieve in the refining stage, how low we need to bring the MCPDE and GE in order to get olein that complies with the buyer's requirements or the EU requirements. Next, please. So we tried to develop correlation for this. So when we tried to analyze it, we found that for 3-MCPD, the correlation seemed to be closer with the IV of the oil. So the ratio of IV tended to be a better correlation of how the 3-MCPD will concentrate in the olein and how will actually be lower in the stearin, right? And we also tried to do a correlation for the GE. And next slide, please. Here we found that it tended to follow more the trans. So this could be a quick indication for what is your possible quality of your refined, what is going to be the GE level in your olein. Most of these correlations studies have been done because the 3-MCPD and GE analysis takes a very long time to obtain. It takes more than 24 hours. In most cases, our plants are running continuously, and we don't have so many spare tanks to put products in. So this gives us a guide as to what would be our quality leaving the plant. And this, again, I have to make a qualifying statement. It may apply to us. You may have to develop your own, but it shows that there is some correlation. We also tried to see whether it had been influenced by the FFA, which is on the next slide. And we're still developing it. There is some indication that it may also follow the movement of the FFA, but it's not conclusive yet. So you may have to study on your own side to see how you can identify a quick method of determining the MCPDE and G levels in your final products. Next, please. Okay, this brings me to the last slide. And what I wanted to say is, as the previous speakers also mentioned, chlorides and the TAGs, DAGs, MAGs are precursors for 3-MCPDE formation. And since these are formed in the deodorizers, like DAG is formed in the deodorizer and MAG may also be formed in the deodorizer, the best way of reducing the formation of 3-MCPDE remains removal of chloride at this point in time. And 3-MCPDE mitigation is mainly achieving by removing chloride from CPO. The earlier, the better. As you can see in some of our slides, we showed that when it's freshly treated from the mill, we get better quality. Water washing removes inorganic chloride. Organochlorides will not be significantly removed. We did show that there is some reduction. Now, washing is seen to be very effective in keeping 3-MCPDE levels low. But we need to be careful of the processing chemicals used. When I say the processing chemicals I'm referring to here are the degumming acids and the bleaching earths, because they also can contain chlorides. And after you've done all the hard work of removing the chlorides, there's no point adding them back in. So we must be selective of the chemicals that we use for this process. Now, while centrifuges have been used in some plants, there are other patented processes that show that simple water washing without use of centrifuge can help reduce chloride significantly too. These are patented in Malaysia, so you should be able to check and find out the processes. These processes also report lower oil loss in the wash water. Now, GE mitigation looks like it requires low deodorization temperatures. That, however, affects the RBD color. So, looks like at the present moment, post-deo treatment seems to be one way to achieve low glycerol ester levels currently. And there are several methods available. There's several suppliers talking about adsorbents, and there are also post-strippers also being proposed, and they will work. There is a tendency for 3-MCPDE and GE to concentrate the olein fraction, which means that we need to target lower levels than what has been specified by MPOB. So at the refining stage, where the 3-MCPDE and GE are formed, we cannot look at 2.5 ppm as a guideline. We need to look at lower levels, and that lower level will depend on your own processes. Once you've actually developed your own correlation on the formation of 3-MCPDE and GE in your respective plants. Next, please. Okay, these are some of the references that we have taken the pathways and methods from. And next, please. These are some new recent articles that actually point to all the problems that we have to face with palm oil. Palm oil facing a lot of challenges. And next slide, please. That's my last slide. I wanted to leave this slide. It was given by my chief R&D head, and I thought it's very apt at this point in time where we are all facing this pandemic. And I think we all realize that we can only solve this by working together. In fact, for your information, both Engineer Mervin and myself are in red zones, and we are presenting remotely due to us being in areas that are high risk currently. In fact, yesterday when we were actually doing practice, we had the ministry officials over here because they wanted to shut down one of my plants. So we're working under a very challenging environment, but we try and we do our best. But similar to this COVID problem, we need to work together. We all need to work together to address the problems faced by palm oil at present with 3-MCPDE and GE, and eventually with the other challenges that are coming and attacking palm oil as well. Thank you very much.
Hi, Engineer Shang. Thank you very much for that. Yeah, I know you worked very hard on it because you've actually considered some of the questions and actually elaborated on your slide. I think listening you are much more informed about the MCPDE and the GE situation. And I'm sure there'll be a lot of questions coming out very soon. Yeah. But in any event, this webinar itself has already attracted many questions. So what we'll do is, I think we'll tackle those questions that came in first, and maybe some of them already addressed by the speakers. But we will see how it goes, and then after that, all the questions that are coming in from the chat itself. Then. So, Engineer Sham, thanks very much for the presentation. I'm sure you and Mervyn will still get further questions. So if we can start with the questions that came in earlier. Can we have the first set of questions, please? You're going to show that on the slides? Yeah. Okay. So as everybody can see, the first question that came in was from Dr. Goh Swee Hong, who is on the Council of Mostar. And his question is, which mills have implemented the reduction of chloride by the various methods, and reducing chloride in boiler water, fertilizer, segregating poor quality oil streams, and washing CPO and so on, to meet the 2 ppm chloride in the CPO guideline? I think any one of you can answer the questions, but I think this is maybe more directed initially at Engineer Mervyn.
Yeah. To answer these questions, in some W plantations, we actually didn't have a mill that comprised of all these methods. I mean through the CPO washing, fertilizers, and segregation. But for us, we have practice in terms of oil segregations and fruit quality segregations, particularly on the premium oil or the superior oil qualities, where we do these segregations to improve the overall quality and the CL content. In terms of CPO washing, in our company, we actually tested in commercial scales trials, but we are yet to implement it yet. But I believe IR Sham's company have been doing that since, through his presentation, right?
Yes, if I may add.
Sham, would you like to add to this?
Sure. In Sandakan region, in Sabah, IJM has already implemented CPO washing in one of the mills, and they are able to achieve around 1 ppm quite consistently. And for IOI, they have implemented for 2 mills, and both of them are also able to achieve around 1 ppm level quite consistently. In some cases, there is segregation of the Iabilica, but in some cases, it is all added in, and they can still achieve the 1 ppm chloride level in the CPO. And for your information, all the IOI mills in Sabah are investing in washing plants, which will be commissioned by end of this year.
Okay, thank you. I think we can go on to the next question. Yeah, I think there are 3 questions here. So you can see that, so you can answer them, I think, in sequence. Which sophisticated mitigation methods are you using in larger refineries? That may already been partly answered. The post-refining method is ultimate solution. Is anybody investing in the works? I think that's the removal of GE. And the analytical method for GE and 3-MCPD is expensive. So do you use in-house methods for the monitoring? I think this will be directed, I think, firstly at you, then Engineer Sham.
Okay. We have one of our plants with a centrifuge, and for the other plants, exploring alternative methods. We believe the alternative methods will work as well. From our lab experiments as well as pilot plant studies, we are quite confident. We're actually going to do some experiments this next month, and we believe it shouldn't be all centrifuge alone. The second question, I believe it will be a combination. We need to do both pre-treatment as well as post-DO treatment. It won't be post-refining to remove everything. In our case, for the third question, we have an on-site Agilent GCMS, which we use for testing the MCPDE and GE. But like I said, it is time consuming, and in most cases, production cannot wait for the results. So we've actually started to develop those tools that we actually developed to give us an indication of what would be the possible MCPDE and GE levels in the final product.
Yeah. So the post-refining, you say that you think that most people would have to do that, and Engineer Sham. Is that another kit to invest in then?
Okay, the pre-treatment will probably be the washing. The washing would probably address mainly the 3-MCPD and not all of the GE. For the GE, looks like it has to be either a post-stripper or an adsorbent, which will be post-treatment. And both methods look like they are viable.
Yeah. Okay. Thank you. Engineer Mervin, you have anything to add to this?
Maybe I will add in on the third questions on the analytical methods. So in SMW plantation research, we have a whole range of ISO accredited lab, and one of the lab, which is the food safety lab, actually we have our internal instruments to analyze the GE and 3-MCPDE.
Yeah. Okay. Thank you. Then we can go on to the next question. Yeah. Now I think the questions have changed. Now they are coming in from the SMAT Balestra. The slides may or may not. I think or I think they might still be the same. Then this is CPO question. So is the process already implemented on the industrial scale? Then this is for SMBS, and is it used by soaking, mixing, or passing through into size extrusion column? Is the process applied to crude oil or to wash crude oil? Can it remove organic and inorganic chlorine with the same efficiency? And then I think there's the question on sphingolipids. Yeah. Okay, I think you found the slide then. So I think Mervin is your slides and the questions that has been directed to then. Yeah.
Yes. So to answer these questions, actually these CPO glycrolinations is done at the laboratory scales. So basically we do mixings as MBS, and then we filter it out. And this method is done on the crude palm oil itself, not after refining. And also this method actually tested out before the degumming stage. And to answer in terms of whether this remove the phospholipid, the organo, can you go back to the question earlier? I forgot the questions.
Can you show the question, please?
Yeah, sphingolipids are the only source of organochlorine in the crude palm oil. So for these questions, actually I already mentioned earlier that we actually, for the crude palm oil, we have more than 200 types of organochlorines, and sphingolipid, it appeared to be the most abundant one. But we believe that we cannot solely focus on sphingolipid itself only, and we need to check also on other OCs in general. So to understand these 3-MCPD formations, our general principle here is that as long the oil contain any chlorinated compounds, it will affect the 3-MCPD E formation. Yeah.
Yeah. I think there was a further question which may be missed out on same subject. And does dosage correspond to organic chlorine or to sphingolipids content?
Yes, it does.
It does, huh?
Yes.
Yeah.
Because as I mentioned earlier, as long you have any chlorinated compounds, it will affect your 3-MCPDE.
Yeah. Okay. Engineer Sham, anything to comment on? Okay, you pass then. Next question, please. Yeah, I think the next question now. We need the next question. We've answered this one. Yeah. Okay, this is on slide 2.6 and correlationship between 3 MCPDE E and GE. Seems that nothing is said about that in the presentation. I'm not sure which whose slides these are referring to, but I think you will know then pick it up. Slide 8, interesting summary of different pathways. I think this is for Engineer Sham then. Interesting summary of the different pathways for 3-MCP formation. So he wants to know which is the best suited in the case of palm oil refining. And finally, slide 14, how do you differentiate between organic and inorganic chlorine? Do you do two separate analysis on crude water and wash water? So wash crude oil, sorry. So over to you then, Sham.
Okay, the first point has already been addressed in the presentation, explaining it in the, what's it called, how the trend between MCPDE and GE in our plan, where they actually go in the reverse direction. So I won't continue further. I think in the earlier slide that was given, it was not attached. All right. The next question, the different pathways. Now, I think in both Engineer Mervin's and mine, you'll see that there's emphasis a lot given on the DAG. So basically, DAG is one of the major contributors to forming the what's it called? MCPD. If you look at the first line, the second line, the third line, the fourth line, you'll find it's all DAG. You see, DAG is in it. So if you look at most literature, they also look at there's 3 to 7% DAG in CPO. So this is one of the major pathways for formation of 3-MCPDE. But I think that is something that you cannot avoid. The moment you form free fatty acid in CPO, you will have DAG in it, right? So we cannot get so hung up on the DAG. It is the other contributing substance that we need to worry about. The third question was whether we do separate analysis on the crude and water. Yes, we do two separate analysis. And actually for the what's it called, for the washing, we do what's it called, double washing. In order to eliminate errors, we wash the CPO 2 times. So we determine the total chloride in the CPO initially, then we double wash the CPO, and then we check the chloride again, and the difference is the inorganic chloride. Okay, and it's done through a chloride elemental analyzer. It's a Mitsubishi elemental analyzer that we use for analyzing the chloride content.
Yeah. So you actually gone back, I think, very nice to show the difference, organic and inorganic chloride. Engineer Mervin, anything to add?
No for me.
Okay, and next question, please. Then. This is on slide 22. Then the settling tank for recovery from the wash oil. What is the preferred option? First centrifuge followed by settling tank, or the other way around to recover the oil from the wash oil? What is the percentage of water used for the settling tank, and what is the temperature and retention time in the settling tank? After the settling tank, what is the water content in the oil? How could the water content in the oil be removed? What is the oil content in the water? How would the oil be recovered? Oh, very detailed questions. Engineer Sham, over to you.
Okay, all right. Okay, for the first question, it is first centrifuge followed by settling tank. So the whatever oil and water that goes into the centrifuge, the separation takes place in the centrifuge. The water phase goes into the settling tank. That's the purpose of that settling tank. Then for the second question, there's no water added. It is phase separation that of the substances that leave the centrifuge. So the water phase that leaves the centrifuge is fed into the settling tank. The settling tank serves as a phase separation between the two materials, which is oil and water, which fortunately have got difference in density. So it is basically using basic principles to separate the two phases. It's a standard settling tank. It is also equipped with skimmer so that it removes the oil from the tank, and that oil is recovered back into the process. The next question, what is the water content in the oil? The water content in the oil is very low. It is less than 1%. And since the amount of oil is very low, we just put it back into the oil that is going back into the centrifuge. So it is rewashed, no problem. It's sent back into the tank that feeds the centrifuge, which already has got water in it. And what would be the water content, the oil? So we don't need to remove the water. The oil containing that water of about less than 1% goes back into that tank, which mixes with oil with say about 5% water, and that is fed to centrifuge. What is the oil content in the water? It's actually very low, but for the purposes of this presentation, we will say it is less than 0.2%. And how would the oil be recovered? Yes, it is recovered in that settling tank by using the separation system in that settling tank, and then using the skimmers in that tank.
Okay, thank you, Engineer Sham. We can move on to the next question then. Yeah, now this is slide 31 and 32. I think it's for you then, Engineer Sham. 3-MCPD seems to correlate with the IV of palm oil and fractions, and trans fatty acids are closer to GE ratio. Is there any tentative explanation? And what about the DAG content distribution within the fractions? No correlations with 3-MCPD and GE. You may have answered the question in your slides, but maybe you just elaborate on it. And then slide 34, while centrifuges have been used in some plants, other patent processes show that simple water washing without centrifuge can help reduce the chloride level significantly too. These processes report the lower oil loss in the wash water. Which patents are referred to? I think this may also be referring to the a recent liquid extraction process. So over to you then, Engineer Sham.
Okay, as I mentioned during the presentation, the 3-MCPD and GE testing is very tedious. So what we have been looking at is a faster method to determine what would be the 3M and GE in our products. So again, a disclaimer here, this could apply to our refinery and may differ for others. The local university, UPM, is also doing correlation using indirect determination, and the accuracy compared to GC is still questionable. So look, I think each of us needs to do their own work or homework in order to determine if there is any fast way to determine the 3-MCPD and GE. For slide 34, I think you're referring to a statement that I made there. What I mentioned is there are patented processes, and I don't think I'm at liberty to mention which patented process, but I will mention that they are Malaysian patents. So you may be able to look them up. And I don't think here at Mosta or ICAME we want to be seen to be promoting any particular industry or any particular patent. So it's up to each company to try and see which works for them. I believe there will be a launch of one of those patented processes very soon. That's what I was told. But maybe things have been delayed with this pandemic. There is a proposed launch for one of those patented processes very soon, and it may have been delayed slightly because of the pandemic. So stay tuned.
Okay. Yeah. All right. Yeah. Yeah. Engineer Mervin, if you have anything, you just say so, because I think these are more meant for Engineer Sham. Yeah?
Yeah.
Okay,
so
next
far,
question, please.
Nothing from me.
Okay, next question, please. Oh, this is from JC Chang, and it's very specific and for you, Engineer Sham. So you presented 6 pathways, and it's going to ask for 3-MCPD formation. It's going to ask which one is most likely to happen. I think you may have partly answered the question. And also for IV, the ratios are very close among palm oil, olein, and stearin. What does this indicate? And finally, regarding the settling tank, he asked about the working mechanism of the tank. Sorry if you have already answered these questions, but maybe you just want to just clear this up then. Engineer Sham?
Okay, actually, they have been answered. I've actually also built it into the presentation as well. And again, the purpose of presenting this was to show that 3-MCPD forms PAG, DAG, and MAG. And in the presence of chlorides and at the refinery processing temperatures and conditions, that's when the 3-MCPD can form, right? But of interest, I think both for 3-MCPD and G, a lot of it interest is towards the DAG. Pathways, we're just trying to see what are the possible pathways. I don't think we want to actually say any of them is actually more prominent than the others. Again, regarding the ratios, again, I've already explained that what we're trying to show is we are looking at a faster way to determine what would be the 3-MCPD and GE in our products, because the actual testing methods takes an extra 24 hours using the GCMS. So until a faster method comes, we need to find some other quick method ourselves. The working mechanism of the settling tank. The settling tank is basically just like your any settling tank, which uses gravitational separation of material of two different densities. It's actually very simple. So you need to have sufficient area, sufficient time, and in fact, there is no added temperature as well. Whatever comes out from the centrifuge is fed into the settling tank. There's no added heat or cooling down or anything done. We just use it as it is.
Okay. Yeah, thanks, Engineer Sham. Next question, please. Yeah, I think this is still from JC Chang. So any specific temperature to be maintained? I think you've answered that. And what is the retention time of the water inside the tank? Maybe this is the one, Engineer Sham, you have not answered then. You want to just address this before I go on to Engineer Mervin?
I didn't want to answer it because, look, again, it is no one size fits all. You have to work with a person who knows how to design a settling tank and then get the best out of it. Yes, he is right. There is some retention time. There's certain areas, there's certain ways that they actually optimize the space that you have. So it's best to work with somebody who's competent in that area to design it for you.
Yeah, probably a chemical engineer.
Correct. If I'm going to give a certain time without knowing his actual process conditions, it may end up backfiring, and then they'll say, hey, it doesn't work. You see. So it's best to actually work with somebody who is in this line. That is what we did. We actually worked with somebody who is familiar with it. We didn't stinge on it. We said, okay, look, let's get this done properly. We already had a settling tank. Okay, let me go back a bit. When we did our CPO washing project, we didn't buy it off the shelf. We actually bought the centrifuge from one company. We put all the other equipment together ourselves and designed the process ourselves, including we got a settling tank from one particular company. Now, once you were not happy with this settling tank, we engaged another party to actually redesign and do a settling tank for us. That's when it worked.
Okay, thank you. So we go on to Engineer Mervin then. I think the next questions are addressed to you. In one of the slides, you presented the washing of palm oil fruits that could reduce the total chloride content by 30%. Have this tested before? And then how does FFB washing help in reducing FFA? Please elaborate on this. So over to you then, Engineer Mervin.
Yeah, thank you, Ayakwa. So for the first questions, regarding the reductions of total chlorides in the FFB washings methods. So to answer the question, yes, we have tested in the lab scales, pilot scales, and even the commercial scales. So we found out that through these washings, there's actual reductions of the total chloride contents after washings. Regarding on the second questions, how does these FFB washings help to reduce FFA? Yes, these findings actually caught our surprise when we do the trials. So what we can postulate here is when we do the washings, there's two possibilities here that we can project, which is number one, during the FFB washings, some of these oil, especially the outer layers, was washed out during the washings, which contain high FFA. Secondly, most possibly also that trash contents that contains whatever catalysis catalyst of these hydrolysis might be also washed out during the washing systems, which these two we are doing some testing on to confirm the findings. But I think just my explanation doesn't prove this whether is it true or not. So maybe I give a suggestions for you guys. If you want to check whether this finding is true or not, maybe you can get some loose fruits from your side and then you do some washing and see what's the difference between the FFA. Yeah.
Okay. Thank you, Engineer Mervin. That I think that was a very interesting finding. You got people interested in that. Okay.
Yeah,
Give
I
me the
mean
next.
this.
Yeah. Sorry. Carry on.
I mean these results can be proven if you do your testing yourself and then see whether is it work or not, right?
Yeah. Correct. Okay. Thank you, Engineer Mervin. Next set of questions are from AAR, and that's the question for Engineer Mervin.
Yeah.
He wants to know what is the analytical method used in quantifying the organochlorine for your data shown on page 17. So that's
Yeah.
to Mervin. I don't know
Yeah.
whether Engineer Sham wants to answer also together or not, because can I know data or no? Okay, it's okay. Carry on with the first question then. Sorry, Engineer Mervin.
Yeah. For these results, actually we use the liquid chromatography, high resolution mass specs, means LCHRMS. So to further details on the analytical methods, actually I already provide a reference in the previous slides. So in the sphingolipids ones, so you can refer to reference 14 in my slides. So this is one of the trials done by my colleagues, and you can see what's the details in the methodology part. So this method actually is a published method.
Yeah, thanks for presenting. Yeah. Okay. And then the question for Engineer Sham then, can I know the data shown for the chloride, page 14, and how many replicates are there for washed and unwashed CPO? Engineer Sham?
They're done in duplicate for that particular experiment, but they actually repeated over time. So many experiments have been done even recently. You remember I also mentioned we also were surprised when we actually had a reduction in the GE level just from washing. So we also repeated it after some months, right? Because it could also be with different CPO, you get different results. So we actually have repeated it again and again. Although it may not show similar reduction, we also do see reduction. So they're all normally done in duplicate.
Yep. Okay. Thank you. Next question, please. Okay. I think this set of questions are from Excel wide. I hope that our speakers are in a position to answer this because I think it's on downstream. Any technology or method in place to strip the three MCPDE and GE on downstream products like palm oil derivatives? Any data or information shown on the trending of 3 MCPD and GE in palm derivative products and how many times folds? Any specs established for palm derivatives concentrated fraction like enriched fraction of palm vitamin E and palm keratin, which I think are Excel White's products. Yeah. Any one of you like to answer this or start with this? Engineer Shah?
Okay, I'll give it a shot. Okay, basically we mainly look at our downstream products. So we look at what happens to the olein and stearin. As you see, we did correlation and we can find that from the palm oil, it does concentrate in the olein stream and all that. And like we mentioned, there are technology providers who are trying to provide strippers as well as adsorbents for removing both MCPD and GE. I believe that they should also pursue this route as well. For the first question, for the second question, you can see that what we have shown is there is a trend for the MCPD and GE to concentrate in the olein. I believe the same could apply to Excel White's products, and they should study it as well, because like for us, we'll only be concentrating on what affects us and affects our customers. We haven't gone to the level of looking at supplements like this.
Yeah, okay. I think on the last one, you may not be the person to be able to answer the question. Yeah. So, Over to Mervin. Anything to add?
For the first questions, I got not much knowledge in terms of the downstreams, but however, I think that if we can reduce the precursors or 3-MCPDE GE level at the feed level, we can definitely reduce it at the derivative area. Also on the third questions on the established for palm oil derivative specs. So if we if I understand correctly, these are meant to like something like a food product, which means something end products. So it's best for us to refer to our Food Act 1983 and also Food Regulation in 1985. So all these specs should be actually enlisted in the MOH so that we can know what are the specs inside. Yeah.
Yeah.
That's all for
Okay.
me.
Yeah. Yeah. Thank you, Engineer Mervin. Okay. Can we have the next question? I think these are now the new questions that are coming out from the Facebook. I wonder how much we have then, but I think we still have time then. Okay. I think we'll just take the question one by one, so that I think it makes it easier then. Yeah. So the first question is from Meva Oil. When CPO dechlorination trials are done lab scale, is it done before degumming and bleaching? I think some of this question may already have been answered, and so maybe over to you, Engineer Sham, very quickly.
We have done a mixture of both. Of course, bleaching comes after, but we have done both washing before and after degumming. Sometimes we also did acidified, slightly mildly acidified washing as well to see whether it will help in the degumming as well. But in most cases, bleaching came after.
Yeah. Okay. The next question then is from IGM Plantations. Yeah, he's asking what is the capex in the SMBS process, and your results seems to show that there is a relationship between FFA and total chloride. If so, could you explain the mechanics of the relationship? So I think the first question is for first two questions are for Engineer Mervin. Yeah.
Yeah. So
So
for the first questions, on the capex of the SMBS, for until present, as I mentioned earlier, we are doing this in the lab scales, so we don't have the capex for the SMBS for now. And as I mentioned earlier, the cons for these methods is high oil losses, and also the OPEX cost is high. So to answer on the second questions, I believe this one is related to how these improving oil qualities affect the TC contents. As I mentioned in the previous few slides earlier, that improving the FFA actually improve your DAG's contents and also MBG contents, which indirectly improve the qualities. Also, the reductions of FFA actually reduce the acidity of the oil itself. So in a way, we actually reduce the TC contents in the oil. Yeah.
okay, thank you. Engineer Sham, then I think the next question is for you. In your opinion, refineries in general, how ready are they able to reduce the GE to meet the target in actual production?
The two different levels for palm kernel oils and its derivatives. I believe the refineries are able to meet the levels of 1.25 ppm MCPD and 1 ppm GE. But the challenge is that buyers want even lower levels now. They're talking at levels even below 0.5 MCPD and GE, even lower than that. For palm-based products, while the 3-MCPD seems to be something that is within reach, the GE level of 1 is a bit of a challenge. So MPOB's deferment of the deadline has given us some breathing space to actually achieve this. There is a lot of work going on currently, whether it is with post-geo stripping or with absorption, to remove that GE, and they're all showing positive results.
Yeah, thank you for that. And next question. Oh, it's good to see Dato' Parvez online. Huh? So he has a question here. Why premium palm oil still have high GE content then? So yeah, maybe engineer Sham, you'd like to start?
I think this one is from my part.
Yeah.
You, is it? Okay, sorry.
Yes. So as I mentioned, this premium oil in the slides, that this oil actually produce refined under normal physical standard road. Mean to say that we didn't do any process modification in the refinery stage. But if you can see, there's a reduction of GE from using the standard oil until to the premium oil. However, if we were to use the modified process condition in refinery, we're actually able to reduce lower GE for this premium oil. Yeah.
Yeah. Okay. I think you did show that in your slides as well. Yeah.
Yes.
Okay. Thank you, engineer Mervin. Oh, we've got the question from even the oleochemical guys and Sina Oleochemical. So does washing refined oil reduce organic chloride? How to reduce organic chloride that is present in refined oil? What is the water ratio for washing 1 metric ton of oil then? So who would like to take this question first?
I'll try it. We don't really wash refined oil because then it introduces a new problem on the quality, stability of the oil as well. Then you have to dry it again as well. But it doesn't reduce. From what we see, if you just use water, it cannot reduce unless you decide you want to use alcohol water mixture. So you need something that can go into organic compound to reduce the organic chloride. To reduce organic chloride, the present refined oil, there are some adsorbents that claim they can do it. We are doing some experiments with it, and we are waiting to get some promising results. It depends on the degree that you need to remove, because the adsorbents can end up having to be consumed quite a lot. Water, referring to water for washing of RBD oil, I wouldn't know, but you're talking about CPO, it ranges, I think, from in the mills and refinery, we're looking at something like 5 to 7%. Of course, the more water you use, the more chloride reduction takes place, because like I said earlier, it's actually basically dilution that is taking place. It's not really washing, you're diluting the chloride content in the oil.
Mm-hmm. Yep. Okay. Mervin, anything you want to add?
So far, nothing much from me. But just like Ayasham was mentioning, CPO washing is a dilutions. So if we check through the moisture content in the CPO, it does also affect the chloride contents in the CPOs. So if you have a very low moistures, some of the result findings that we see is that the the chloride content is higher when you have low moistures in the CPOs. Mean to say somehow the oil with the low moistures concentrated at the CPO.
Okay, thank you. Next questions, please. Yeah, next question is from MEOA. Is the data showing a wide range of organic, inorganic composition CPO derived from one plantation? What are the reasons for such a range? And I think this question is, he's got, yeah, I think let's just take the question one by one then. I think the question is directed for you then, Engineer Sham.
Yeah, our data was from many different suppliers. It's not from one plantation. We take oil from all the plantations in the Sandakan and Lahadatu regions. So it was not from one particular plantation. But you are right, there are also variations during seasons. When one particular mill can give us low chloride at a particular season, the chlorides can be higher in another season. So we cannot draw a conclusion from just taking spot samples like that.
Okay. His next question is it feasible to reduce, well, now he's using 3M also, by averting pH condition by using dry enzyme degumming or alternative to acid-activated bleaching earth? Yeah, we still stay with you then, Engineer Shah.
There are companies that are promoting enzymatic reactions. I am not an expert to be able to comment on whether it can or cannot work.
Okay. Next question, I think is for you, Mervyn. That's on your slide 17, where you indicate 4 ppm organic chloride in CPO, which cannot be reduced by washing, and implies that after about 4 ppm, 3M after refining. I'm confused.
I'm sort of confused with the question actually. Can we go back to the slide 17 to see that slide? Is it possible for me to see slide 17?
We think, can you show slide 17 from Saim Dabi?
Okay. So this is a slide 17. So this nothing to do with washings. This is a normal dilutions. So if washing to be in place, there's a potential that we're able to reduce. But as I shown here, this is organochlorine contents, which mentioned by IR Sham also, there's limitations for the CPO washing in removal of organochlorine content. So I think
Yep.
I believe I answered the questions.
Yeah, okay. Thank you then. Yeah, question 6 is from Excel White again. Not quite sure what is the washing parameter of CPO. I think I'm not quite sure what the question is, and either one of you can figure out what this is.
Okay, let me say that okay, when we wash CPO, we use hot water, and we try to use water which has low chloride as possible, and it is done at about I think just about just below 100 degrees Celsius, and fed to the centrifuge. There is some mixing stages that go on beforehand. There is some what's it called, acid addition, depending on the process. You may want to do some pre-acid, or it could be post-acid. It depends on each individual operation. But the mixing is important. You have to have a intimate mixing between the water and the oil, because it's two different phases, and that is where the dilution actually takes place during the mixing stage. The centrifuge just separates the two phases from each other.
Yep. Okay. Mervyn, anything you want to add along those lines?
No.
Okay. Can we look for are there more questions after this? Oh my goodness, there's so many. I was told there may be a lot of questions coming. I think we probably want to maybe go on. I think it was okay for the speakers, and maybe for another 20 minutes. Yeah, then I think we probably want to cut off then. Okay, this is from Novozymes. Yeah, what causes the formation of organochloride? Will the inorganic chloride turn into organochloride over time in the tank farm? And then what is the best available process technology to remove organochloride from CPO, since it plays an important role in the formation of 3-MCPD? And it refers to your slide 22 then, Engineer Sham. And I think this question is already asked and about the settling tank retention time. What post-DO treatment are you referring to in your study? That's for you, the Engineer Sham. Can the post-DO treatment remove 3-MCPD and GE? I think you didn't detail that, but maybe you just want to quickly just answer the question, and we pass this one through then. So over to you then for the whole set of questions, Engineer Sham.
Formation of organochloride is from the process of forming of the oil in the mesocarp itself. It is a natural process. From what we've studied over some period of time, the inorganic chloride doesn't turn into organochloride in the temperatures that we see in the tank farms. If you're running at about, even if you heat it up to 50 degrees, if you normally do to heat it up to supply to the refinery, or even for shipment purposes, we don't see any pickup in the organochloride. So the inorganic chloride remains basically as inorganic chloride. But again, there could be certain substances that could catalyze that formation, and it could be happening. For removal of organic chloride, sorry?
Yeah, carry on.
Yeah, the best available process technology to remove organochloride, again, it is best that you have low organochlorides coming to CPO. What we have to do sometimes is to actually see the different incoming streams of CPO, and we actually blend it in our tanks to actually get lower levels that are fed to the refinery, because we get many suppliers supplying, right? So we can actually have a range of inorganic organic chlorides, so we can actually keep it within certain levels. With the level specified by MPOB and in our plant, right, I think we are able to achieve the 2.5 ppm level quite comfortably, even with the incoming organochloride levels in the CPO. Of course, it could differ from season to season. So we've got to see what actually happens in the longer term. The settling tank question I have addressed earlier. I do not want to specify any particular time, because it actually depends on various parameters that will be best designed by the designer himself. I think there are certain dynamics involved in the separation between the two phases. I studied this probably 40 to almost 50 years ago, and I've forgotten most of it. And it is best that somebody who's actually conversant in that topic actually address that particular question. I think there is a tendency for us engineers, he did it, let me copy paste and do it in my refinery. I think that is where a lot of mistakes have actually happened. We should actually take the trouble of actually looking at the design, studying it, doing the calculations, and letting it go from there. It also may depend on the space that you have available to put up those tanks as well. Of course, the longer the better. If you can do something with a very long retention time, it will probably give you better separation between the two phases. In the post-zero treatment, we're talking about adsorbents. We did two. We did thin film deodorizing. We did also adsorbents, and the thin both. It was actually removed both. Unfortunately, with most of the adsorbents that we studied, they remove either but not both. We've not been able to remove both with the same adsorbent. So it's just like you go to one column to remove one, and you go to another column to remove another with adsorbents. The thin film has been able to reduce some of the GE, but we need to do more work. And I believe the technology providers are also working along that direction. They're actually looking at post-strippers, and they have, I think they are already in a position to propose plans for removal of GE.
Yep.
Yes.
Okay. I think we need to try and move a little bit faster. I hear there's something like as many as 20 questions to come. So let's try and go through that quickly. Next, please. Okay. Yeah. Can we skip the CPO washing by introducing post-deo treatment? Does post-deo treatment remove GE through stripping them or preventing the formation of GE? And I think this question stays with you as well, Engineer Sham. In CPO, there are traces of inorganic acid or mineral acid. Measure pH water extract from CPO or bleach palm oil and correlate it to the formation of 3 MCPD in the deodorizer.
I guess for the first question, I guess you could look at skipping if you can find some method that can strip both the GE and the 3 MCPD subsequently. Our finding is it's quite difficult to strip the 3 MCPD. The GE is possible. The 3 MCPD looks like it's a bit more difficult to strip, right? Yeah, and for the second question, CPO with inorganic acid. The CPO shouldn't have any inorganic acid or mineral acid in it. As I mentioned earlier, when we do washing, we do consider mildly acidifying the wash water so that it aids in removal of some of the minerals in the CPO so that we get better quality of washed CPO. It does do some mild degumming, and That's why you see some more of the phosphorus as well, and some other impurities are removed together with that washed water.
Yeah, this is phosphoric acid.
Yeah. We've looked at both. We've looked at phosphorus, we've looked at citric acid. Again, depending on your process, you may find benefits in one or the other. Sometimes when you add citric acid, you're able to remove more of the organochlorides as well. That's what we know. But it's not a significantly larger amount of organochlorides that we remove, but because it's an organic molecule, or it can penetrate into the organic barrier as well, you are able to remove some of the organochlorides as well.
Yeah. Okay. I think question is already answered. We move on to 9. Sun Group. Oh, I can see that now. What is the Z-score proficiency test example FAPAS of your lab? This is a little bit beyond me then. Who can answer this question then?
Not me.
Engineer Sham or Engineer Mervin?
I don't even know what that is. But
it's a little bit beyond me, so I can't help you on that. If you can't, we just skip it. Maybe you'll get Mr. Yong Chen to rephrase the question, and it'll come back up at the bottom of. Yeah. So we move on to the next one. From AEN Palm Oil Processing. Any method for washing CPO, water, and oil? I don't know whether this is a general question or not. What should the temperature we should maintain? I think this is already answered then. Maybe we should skip that. We take the question from Agri, page 16, iOS slide. If you use CPO washing, how many % oil loss? What is the ratio of water consumed CPO? How much % added to pomade, and what kind of? I'm sorry, I can't see the. I can't see the question at the bottom. What kind of water use is it? Yeah, my screen is blocking it then. But I think you have addressed most of this, and Cham, maybe just a very quick move on to the next question.
I think most of it has been addressed.
Yeah. Cham, you want to answer that question 11 quickly?
Okay. Can we go back? Okay. All right. Oil loss is how much? Less than 0.2%. Less than 0.2%. I said oil loss in the water, which means if you convert it to the CPO, it's actually even lower than that, maybe about 0.1%. Ratio of water consumption is we use 5% in our plant, but there are some people who got to higher or much higher to double that. Added pomade, we don't use the term pomade here. So the 5% water goes into your effluent treatment system, which is able to be handled by our existing effluent plant. Because we put in the settling tank, the BOD levels are not very high. It is able to be handled by our existing effluent treatment plant. We've also improved our effluent treatment plant, so it's able to handle. We also simplified it as well. Water is used. We use condensate. Okay, we use condensate that we recover within our complex, so we don't need to reheat it. And also condensate has got very low chloride content, which is good. But again, chloride is low in a refinery condensate. But that may not be the case for mill condensate. So you need to watch what you use in your mills. Do we add any chemicals? Yes, we do mildly acidify it. We do test with both phosphoric and citric acid. There are benefits in using both. But we find that the best degumming is still achieved using phosphoric acid. Next.
Yeah. Let me see. Okay, next one, please. Yeah, I think this may be the last question. If there are any more questions coming and we don't have time to answer that, we will take it up with the speakers and then probably email you the answers. So the last question is from Mr. Chandran. Yeah, thank you for emphasizing the need for reducing precursor chloride in your presentation. I note the slide on MCPDE E and G formation and factors refer to the presence of lipase enzyme on fruit surface and the presence of lipolytic microorganisms. All palm understands as an active endogenous lipase inside the fruit, not on the surface. Any particular reason why this is not mentioned? Then in Mervin's slide on mitigation strategies, reduction of 3-MCPD precursor, it is claimed a reduction in total chloride TC. The question is total chloride up to 30% and by 40% FFA cleaning. Is this really achievable? Is the speaker suggesting cleaning the fruits get rid of lipase enzymes on the surface? Most of the FFA surely comes from this action inside the fruit. I think it's your question then, Mervin.
Yeah, I think for the first questions, agreed that lipase is from the fruit itself. But if we compare a bruised fruits and a non-bruised fruits, so the FFA definitely will be affecting the quality of the CPO, right? So what I mentioned here is the reductions of these FFA, potentially reduction of these FFAs is because we are some of these oil that at the bruised layers actually remove out, which is mean to say that these partial reductions of this FFA is because we already remove out this high FFA CPO at the outer layers, means on the bruised areas, but not inside the fruits itself. On the second questions on the reduction of FFA, actually I already answer in the earlier presentations, but to whether prove it, is it achievable, rather than I claim yes workable. Of course I know that it's workable. Maybe as I mentioned earlier, your site can also do the testing on that. And I'm not suggesting that the lipase enzyme is washable through water, because as we know that lipase enzyme is not possible to wash through waters. But what we say that here is there's the potentials that this high FFA CPO on the surface has been washed out, or any microbial activities or catalysts that induce hydrolysis has been washed out during washings, but not the lipase enzyme in the fruits has been washed out. Yeah. Hope I answered the questions.
Yeah, I think it's interesting that you're trying to offer some of the reasons for it. But what is interesting is that you actually been finding that happening, and I think it'd be very good to continue to investigate that, and maybe other people, as you suggest, can also try and find that out for themselves. So we've almost come to the end. It's getting to be 12:30, and so as I said, any further questions that are going that we do receive after this, we'll try and get it answered by email later by the speakers. But in the meantime, I think the two of you have, I think, done a very fantastic job, and sitting with us through 2.5 hours now. Sorry, and I do apologize for the beginning part where I was supposed to be involved, but something went wrong on my internet, and I don't know who to blame for that. But the two speakers have more than made up for that. And I also thank the audience for the very, very good range of questions. Of course, inevitably, there will be some overlaps. But I think the speakers have actually taken the trouble to address questions. And I think it's very good that this is I would think this is the first time, because Mostar has actually been encouraging the work on mitigation of 3-MCPDE. And I think we have had a lot of good support from technology solution providers. And this is the first time that we have seen the industry players themselves coming up to share the information. And I think we should all be very grateful for Engineer Sham and Engineer Mervin for coming out and the organizations to agree to share with us. So with that, I think together with the on behalf of participants, we'd like to thank Engineer Sham and Engineer Mervin for the presentation and for answering the questions during the question and answer then. Yeah, so thank you very much. I think Mostar has one announcement to make, and so maybe I just need to ask them to show the slides then. Yeah. I think there are no webinars planned after this, and the next event for Mostar will be next year on February 25th, 26th at Hotel Istana. And I think this program is postponed from September this year because of the pandemic. I think what's going to be unique about this OFIC 2021 is that it's going to be a combination of both physical as well as virtual. And so I think that will prove to be quite interesting, and hopefully it will reach out to even more people then. Yeah. So that's, I think, is the final and is the announcement from Mostar before we go off. So I think, yeah, it's time for me then to thank all of you now, the speakers, on behalf of the participants. And so thank you very much, and keep safe.